Hello and welcome. This is Anand Kothari. I'm one of the product management within our Oracle Cloud platform, looking at our application development services. And I'll be talking today about Cloud Foundry Service Broker, how it helps bridge cloud native applications built on Cloud Foundry with other backend services to grow the ecosystem, to give developers the choices of a lot of backend services that they can use with their cloud native apps. So I'll talk about that. I'll talk about the general concepts of Service Broker and Cloud Foundry, as well as some very specific things Oracle has done to bring Oracle ecosystem to Cloud Foundry developers through this Service Broker. So let's get started. I'll give a quick overview of the Cloud Foundry system so that people know what we are talking about, and we will see the rest, how the ecosystem grows through the Service Broker in the rest part on the service. So what we notice is that, and you probably have noticed similar patterns, is that in 2017, this year, a lot of different models of application development. Containers are growing. People are building a lot of container native development. Essentially, that means running Docker on Kubernetes, directly creating your Docker images and managing them through some pipeline, and then running them on a true Dockerized environment. A little bit more infrastructure centric, but that's a pattern. Over the years, over the last decade or so, we have seen a lot of enterprise Java pattern development, and in Cloud Foundry and some of these other competitors falls into what we call the cloud native space, which is a little bit higher level than container native, and though underneath it, they use containers, they use Docker and orchestration and scheduling models, but they're not exposed to the user. To the user, it's really an application centric PaaS platform. You take an app, you push your app, you give a little bit characteristics about your app in your descriptor, and that's about it. The rest of the setup and configuration and cluster management and security, all of that is taken care of the cloud native platform. There are a lot of those platforms. I'll talk about that in a minute, but they support many different languages. They're polyglot in nature, so that you can develop applications across the board. um, and that's what we'll focus today. The idea here of this platform is just push your code, and the platform does the rest. Underneath, it uses the concepts of container native or the components of container native platform, but that's not exposed to the user. Therefore, it is less burdensome from administrative point of view. We'll talk about that, and we also see a lot of visual development model, but that's not the focus of this conversation. Let's get to the cloud native PaaS, where Cloud Foundry fits, and then talk about Service Broker that expand is the ecosystem of this cloud native platform. So how many platforms are there? Actually, there are a lot more than this slide suggests, but I just picked the big, most common, most well-known names. Cloud Foundry, obviously, that's what we are talking about. The cloud Google Cloud Platform. Again, this one has, if you remember, a service called Google App Engine. That's essentially a cloud native PaaS. You push your code and it does the rest. OpenShift from Red Hat has a similar model. Heroku is the one who actually started this, essentially this model a long time back, and has a very successful service. Salesforce has acquired Heroku, and that provides you this exact same mechanism. Push your code, and Heroku does the rest. Oracle also has a platform very much similar to that. That's not the focus of this conversation, but there is an app container platform within the Oracle PaaS ecosystem. So these are the big ones, and there are few others, but this gives you an idea of how vast and how big the cloud native platforms are, and there are millions of applications and thousands of customers and users using these platforms today to build agile, very quick applications and in various different languages. This is essentially a bird's eye view of what Cloud Foundry is. This middle box is essentially the platform. It provides all these capabilities within the platform around routing and container management. It's all hidden from the user. The user just has to build your application in one of the languages. It also supports to bring your own build packs. So essentially, you can bring your own language, so to speak, if you don't find anything appropriate out of the box. These languages are directly supported, and the only thing the developer has to do is essentially push the code, cf push, and the platform does the rest. Sets up the container environment, sets up routing, sets up all the configuration and dependencies, and underneath to the administrator it provides capabilities like zero downtime, failure and recovery, easy scalability, security and patching. All of those is just provided out of the box, so becomes very easy to write applications. But one of the most important thing, and that is the conversation of this session, is how do you expand the capability of this platform to talk to other services, the services that cannot run on this platform. And Cloud Foundry provides a concept of bind. Applications can bind to these backend application services. They could be data store services, or like a database, or object storage, or documents. They could be some specialized vertical SaaS solution, etc. There could be many things that can run outside of these applications that you want to, or the developer wants to use. And how do you use that? Well, you use it via concept of bind, and that's where the service broker comes, that allows these services to be brought into the Cloud Foundry environment so that developers can then bind to it and use it. And that's what we'll talk about in the next few slides. So why is this needed? Well, the fact is that the cloud native platforms not necessarily can and want to run all sorts of workloads, right? You may not want to run specialized workloads. If you're running special analytics that can run on very special hardware, well, that's not where your Cloud Foundry environment will be running. So it has to be treated as an external service. If your cloud native platform is designed for 12 factor, typically these applications, one of the factors about 12 factor is that they are ephemeral style application. There is no storage in this platform for workloads like database to run. So they have to run outside as an external service. And if they are running outside, then the application that are running in Cloud Foundry need to consume it, need to connect to it, need to use these backend services, right? The database, object, etc. Um, Only then you can write a comprehensive set of solution in this environment. Well, to do that, you need a catalog of service, or an easy way for a developer to find out what services are available. An easy way for an administrator to say, well, let me register a catalog so that my developers can search them and use them. And then when the search developer can find one, they can very easily bind an application to one of the services within the catalog. And that's essentially improves the velocity of the developer, allows fast to market, allows developers to use all sorts of capabilities that are outside of the platform to build rich environments. So that's essentially the need and the reason why Cloud Foundry has extended its model to allow external services, external catalogs to be brought in this model of marketplace. So it has a marketplace. It's a catalog of services. These services all um, provide their own deployment models. They can easily be integrated or bound to an application running in Cloud Foundry via a simple bind command. And the way all this magic happens, everything comes together, is through this concept of service broker. So if you are a catalog service provider, a backend service provider, you have to implement a set of APIs called service broker API, and make them available. And then the Cloud Foundry administrator can go in and register a broker, your broker, into the Cloud Foundry environment, which is what I'll show you in this session. And once it's registered, your developers can automatically look up the marketplace and start creating this service and start binding them, etc. So all the magic of Cloud Foundry being able to look up or bring a marketplace into the environment is why this service broker concept. And this is at a high level how it looks like. Cloud Foundry has two extensions. One is for what I was just talking about, the service broker API that you see on the right side, the red box, which is there to enable these external services, a catalog of services from any number of providers, to be brought in or made available to the developers on Cloud Foundry. So there is a rich ecosystem for development. The second is, of course, the Cloud Foundry environment needs to run on some infrastructure. So the box at the bottom, the horizontal box which says Cloud Orchestration, is the other extension piece Cloud Foundry has to allow it or Cloud Foundry to be deployed on different infrastructures, whether it's OpenStack, whether it's Google, Amazon, Microsoft Azure. Obviously, Oracle also has one implementation. It's a CPI, a set of APIs you have to implement to bridge the canonical model of Cloud Foundry's infrastructure needs or ask into the actual APIs of the backend platform or the infrastructure platform. And once you build that and it's there, the entire Cloud Foundry ecosystem can be deployed on that particular infrastructure. And then through the service broker, you can talk to the rest of the service outside in the marketplace. So we'll concentrate on the service broker for the rest of this conversation. So what is service broker? I've talked already a bit about it, but just to set the foundation right or context right for the rest of the session, it enables integration of services, external services or backend services, however you call it, bringing them into the Cloud Foundry ecosystem. um, what does that allow you to do? Well, it allows you to do a catalog management, essentially look these up as a marketplace. And as through those APIs you can start provisioning these services, backend services, deprovisioning them or create or delete them. And once they are there, you can also bind to them from an application, so that now application can actually use that service, connect to it, unbind when it's not needed, and finally update those services. Now, Service Broker is not just available for Cloud Foundry. It's become an open source or a separate project called Open Service Broker API. And the key reason for that is the model of extending the ecosystem or the marketplace applies to other platforms. So for like Kubernetes or Cloud Native Foundation, CNCF, um, if you're building on a container native environment, the same concept applies. Application built there may need external services, and the best way to extend them is to use this well-known model of service broker. So service broker not only just works for Cloud Foundry now, it also works for Kubernetes, because you can use that within that container native environment to talk to backend services. We'll focus on Cloud Foundry for the rest. Here is a little bit more detail about what broker does, specifically those broker APIs. So on the left side, the blue side, is Cloud Foundry. This is where the AR apps are running and they need to talk to an external service. On the left side, the yellow side, is the backend service. Remember, the backend service is running outside of Cloud Foundry, not inside. But the application that is running inside Cloud Foundry wants to bind to it, use it, right? But how does that work? Work. So first step, the service provider has to implement a service broker API. There are essentially 5 APIs that they have to implement. A catalog API that essentially is a browse or listing API, a create or a provision API, a delete or a deprovision API, a bind API. So that is where application says, I'm going to bind to service X, Y, and Z because I want to use it. And unbind is the reverse of bind. These are essentially the 5 APIs to implement. Once they are implemented, now that API endpoint, or if you have a broker adapter or offline remote downloadable piece of software that you can register with the Cloud Foundry. So you go, your Cloud Foundry administrator would then simply register this service broker endpoint. And once it's registered, Cloud Foundry now can call these APIs at the appropriate time for it to bring the service in the marketplace and make it available to the developers. So first it will call the catalog to understand all the services that are offered by this broker. It could be one or more, and all the deployment plans, etc. So you can pull that information, and then once the user calls a CF API to create, it will call the provision API on the broker. It calls, if the app calls bind, then it'll call the bind API on the broker. So that's what it'll do, is Cloud Foundry acts as the middleman here, and calls the APIs on the broker at the appropriate time, so that it makes that service and a catalog of service available to the developers of the Cloud Foundry. Well, there are, as I said, there are a lot of cloud providers that support or have implemented the CPI, so you can run Cloud Foundry on it, and they, virtue of that, they have built the service broker. So here is an example: Google, Amazon, and Microsoft all have built a service broker for, here are a set of services. So if you're running an application in Cloud Foundry and you want to use Google Cloud Storage, well, there is a broker for it. There's a broker for Google BigQuery. So here's an example of how applications running in Cloud Foundry can expand, can use these external services to build richer applications. And therefore, there is a rich ecosystem or rich marketplace within Cloud Foundry for developers to use. And there are a lot many. I just gave you a small example here of the top three one, but pretty much everybody, if you go to cloudfoundry.org and its marketplace, on that you will see a ton of third party providers that have service brokers there and provide services. Okay, so let's quickly see how this works, right? So in this demonstration, I'm going to show you how a local install of Cloud Foundry. I have one with Bosch 2 Lite running on a laptop. Creating, first registering the MySQL service broker from Pivotal, then creating it, and then binding an application binding to that, and then running that application. We'll see that in the next 5 minutes how this whole comes together. But in this one, we are using the MySQL service provider from Cloud Foundry or Pivotal Cloud Foundry. They have a service broker. We'll register that, and then we'll use that to bind to an application. Okay, so here it goes. So the everything is done via CLI. Essentially, here is a list of all the processes that are running on the Bosch or the local environment to make Cloud Foundry work. First, we'll register the API to the CLI. So CF API, and we'll give you the API. So essentially, the CF CLI now can talk to the Bosch environment that I have local, where the Cloud Foundry is running. So when I run CF CLI, basically that triggers a call into this CF environment. Once the API is registered, we would log in, CF login, to connect to that environment, give the username and password, and also the org, which org we are. So they have concepts of org. So there is OPC org. So we're now logged in. We are connected to the CF environment, and this CF environment is running locally. If I look at the marketplace, CF marketplace, there is nothing there. Why? Because there is no service broker registered. Now we are going to register a service broker, and this service broker is a little weird how it is, but there are many ways to do it. This is one way to do a MySQL service broker registration, just because it's also running on a VBox local environment. It's not running anywhere remote. So -d CF MySQL, run errands, and essentially now it's deploying the CF. Actually, it's deploying the CF environment right now. So now I have a CF environment running MySQL locally, along with the actual Cloud Foundry controller, all running on this environment. If I look at marketplace, you saw the MySQL service there registered. But if you look at services, there are none, zero services. So let's create one. So I'm creating a MySQL service, because you have to create that first. The service needs to be running so that you can bind to it, right? So create MySQL, PMySQL is the type, the service name, or 20 MB is the plan of the service, and CF MySQL 1 is the name of the instance that I'm creating. Okay, created. Let's go and look at services again. We should see our service that we just created. It's running, 20 MB plan, creation successful, but it does not have any bound applications. I've also, if you, uh, this creates the service. Let's go next to the apps. There are no apps running in this environment, in the Cloud Foundry environment. So let's push an app, a Java app. I'm in the directory, and it is the cf Java app. It takes about 2 minutes, and at this point the application is running. um, let's clear up and see cf apps. At this point you will see the application running. It started, but remember, the app's not bound to the MySQL. It's just running, and if I were to go to the UI of the app, it says there is an error. It can't find the backend service, and therefore none of these operations will work. So the next step is to bind this application Java app to the SQL. And if I do an env, you will not see any bind information here. The app doesn't know about the MySQL service. A couple of things I have to do about security: just make the two VMs talk to each other. So I have to build this network around it, and bind it. Typically this is done once by the administrator. Don't have to do it ever again, but you still have to do that. Now once this is done, the two environments can talk to each other. There is connectivity between the two. CF bind, this is a simple bind command. Remember, one of the APIs, the bind APIs, this is what gets called. This calls that bind API on the broker, and we'll bind Java app to MySQL 1, CF MySQL 1. Well, once you bind it, you have to restage or restart your application to be effective. Let's see the env again. Remember, there was nothing about MySQL in this, but now there should be. If I go up, you will see that MySQL endpoint is now available to this Java app be deployed. And its endpoint, username, password, everything is there, so the app can start using it. So let's restage, bounce the application, so the Java environment app now knows these new coordinates of the backend service it got, and can start using it. A minute or so, the app gets deployed, it's all running. Let's go to the browser, and at this point, if I hit the browser, the error's gone. It's now using the backend MySQL service, and I can start inserting records. Add a record. We can add one more. I guess we can do that. Jane, add. We can even update. Make sure it works, or delete. Let's do an update. One record one. John becomes James, and we'll add a comment just in case, just to make sure it all works. Okay, so this is essentially now shows how we use the service broker to bind a Java application that's running in Cloud Foundry to a MySQL service running outside of Cloud Foundry via this whole service broker API model, right? We registered the broker to Cloud Foundry. Once it was registered, we created a service through Cloud Foundry, and then we had the app bind to it, restaged the app or restarted the app, and now app has all the coordinates of the backend service, and you can start using it. And Cloud Foundry does all the magic work behind to make that service available to the developer. So this is let's that talks about the entire MySQL environment and how Cloud Foundry is using that. Now, the rest few minutes I'll talk about how Oracle has expanded that ecosystem, brought in Oracle Cloud Services to Cloud Foundry through the exact same model of service broker. Why? Because Oracle, we see a lot of customers, a lot of user asking, "Hey, can we use Oracle database?" Or Oracle backend services, storage, etc., with Cloud Foundry applications. And if you can use MySQL from Pivotal, you can use database from Oracle, or MySQL from Oracle, or any other NoSQL from Oracle, or any other services Oracle has to provide, right? You should be able to use that. So the exact same concept of service broker we have implemented to bring that ecosystem within the Cloud Foundry. Oracle platform is rich. There's lots and lots of services, and the idea is to bring all of those backing services onto the cloud native platform. They are across DevOps, cloud native and container native development, APIs, enterprise development, database, all of those areas. And I don't want to go through all of them, but here is a huge set of services that could be brought into this ecosystem for developers to build applications, rich applications, using all these capabilities from backend services. So why we bringing a lot of demand? We see a lot of customer asking. We have 50 plus services that can enrich the ecosystem of the cloud for the Cloud Foundry developer, right? Simplify the integration with Oracle workloads and make it flexibly run on premise everywhere. So remember, Oracle has done both piece of extensions. One is Service Broker to bring Oracle Cloud services to Cloud Foundry, enrich the ecosystem, and second, make Cloud Foundry run on Oracle infrastructure. So we have implemented the CPI that I was talking, the horizontal red line, so that just like you can deploy Cloud Foundry on Amazon or VMware or OpenStack or Google, you can also deploy Cloud Foundry or Pivotal Cloud Foundry both on Oracle infrastructure. So there is a CPI for that. So now you can have an entire ecosystem running on Oracle Cloud if you wanted. Okay, how does this work? Very simple logic, just like before. On the left side is Cloud Foundry running anywhere. Could be running on premise on VMware or on OpenStack or on bare metal, and your apps are running there in that environment. Now you want to extend and talk to Exadata or Oracle database or Oracle NoSQL or Oracle MySQL, even Java or WebLogic environment, etc. Uh, Running in our Oracle cloud, whether the Oracle cloud is in the public cloud or is on premise in our Oracle cloud machine, doesn't matter. You would want to use that, bind to that environment or those services and use it. So that's essentially what this integration brings, and uses the same service broker concept that Cloud Foundry has, because we have built a service broker for our services. It's an endpoint that you register with Cloud Foundry. It enables a single endpoint, enables a ton of services. So you don't have to go and register for each service separately. You will see that in the demo. And it brings in both PaaS and IaaS services. It can run on premise, on the cloud, or in a hybrid environment. And we have made it available for both the services running on our public cloud, and some of you might know and or might not. Oracle brings all the cloud services on premise on what we call Cloud Machine, part of our program called Cloud at Customer, where all our cloud services can be run on premise as a service, exactly the same service. So both of them can have broker APIs implemented. So no matter where you run, you can enhance the ecosystem of Cloud Foundry. Let's do a quick demonstration of that. Exactly the same demo. Only thing I'm going to replace now is Pivotal MySQL with Oracle Database Cloud Service, right? Nothing else. The Java app now talking to the Oracle database rather than MySQL. Okay. CF Marketplace. We only had one service registered. Remember, now I'm going to register the Oracle broker. Now, the only thing is this broker brings in a lot more services than Oracle database, just single broker, and you will see that because you don't need to install multiple brokers to bring Oracle cloud services within the Cloud Foundry ecosystem. So give a name, then username and password, and the URL of where that broker API is running. Slightly different model. This is called a remote broker rather than something that you deploy locally. But this is the a REST endpoint that implements those 5 APIs, and it's scoped for spaces or all. If I now do CF service broker, I have two: the Pivotal MySQL one and the Oracle broker, right? So two brokers. If I look at marketplace, I have a lot more services: MySQL and a bunch of other services that came along: database, big data, data hub, Java, MySQL, Oracle's MySQL. This is different than Pivotal's MySQL, caching, etc. All these services are now available as extend ecosystem services. So now we are ready to create. Just like we created Pivotal MySQL service, we'll create a database service. give it a name, a plan which is an hourly plan. dbas is the type, hourly is the plan, appdb1 is the name of the service, and then Oracle database needs a bunch of parameters, and you can provide that using a JSON. So I just going to point to a JSON that has instance information additional, and the service is created. If you do CF services, there is the MySQL one, and then there is the new one that we just created, appdb1. No application bound to the appdb one, while the MySQL one, the Java app is bound, right? So if I were to go to the database cloud service UI, or this app essentially is talking to database cloud, so you see an error. Why? Because we didn't bind any, right? We have to bind the Java app to this application database, Oracle database, otherwise it doesn't know how to reach. So same exact command, cf bind service Java app appdb1. It'll bring the coordinates of the appdb1 and make them available as environment variables to this Cloud Foundry application. You do cf restage to restart the application, and now that application has so let's do cf restart restage and Java app, and that essentially bounces the application, and now the application has the coordinates of the database service, uh, the Oracle database service which we just created. Okay, cfenv, just to make sure it is there, hit enter, and here are the coordinates of the database service, where they are, what kind. Again, it supports all kinds, rack, non-rack, all of those kind of support databases are supported in this model. Let's hit the browser, refresh. The error should go away, because now the application can actually bind to the backend Oracle database. So let's just create a record, and maybe even update one, so we pretty sure that this works. 101 James Smith, and updated comment, maybe update, and it's updated, right? So this shows it works well. We'll try delete too. Okay, so this, we just did the exact same thing twice, just to make sure you understand the concept. One was with MySQL, a completely different service provider from Pivotal. Within the same environment, we registered another service broker from a completely different provider called Oracle, and we brought in completely different set of services. Now the same app running on Cloud Foundries can use both of these services from two completely different providers, and all of this magic works because of the service broker model, service broker APIs that providers implement, and Cloud Foundry administer, register them, and thus expand the marketplace. Okay, with that, I'm going to close out with what's possible in terms of how these combinations will work. As you can see, everything can work on premise, which is the left side. For that to work with Oracle, you would bring in Cloud Machine to run Oracle database or PaaS services on premise, and you can have your Cloud Foundry on premise, either on OpenStack, VMware, and it'll work. Everything can be on the cloud, whether on one cloud or multi-cloud, doesn't matter. Cloud Foundry in itself can run on Oracle Cloud because we have the CPI available now, and you can talk to Oracle services in public cloud, or you can have Cloud Foundry running on other clouds talking to services on Oracle Cloud. Again, you have to be careful about network, etc., to make sure you bind to services that are not chatty or has the right amount of network latency between these clouds. uh, Expanding on that, on-premise Cloud Foundry running on OpenStack or VMware, talking to the service broker running on Cloud Machine, whether it's Exadata, standard database, MySQL, NoSQL, or any other PaaS service. This is what we call cloud at customer. The entire cloud ecosystem is at the customer. That's why it's cloud at customer, and in all services are available to the Cloud Foundry. And in this case, Cloud Foundry is running anywhere. It can run anywhere in the on-premise environment. Everything in the Cloud Foundry on our cloud with the CPI we have, and talking to all the cloud services that are available in the public cloud, Oracle public cloud, or combination. Cloud Foundry running anywhere, talking to services on our cloud. With that, I'll close out. That completes the conversation about what service broker is, how it expands the ecosystem of Cloud Foundry. makes it much more richer for applications to be developers to build applications on Cloud Foundry, and how everybody's adding to that marketplace. Many providers are providing service brokers, and Oracle has one too, to bring Oracle services onto the same marketplace. Thank you very much, and I for listening to this session. I hope you liked it.